Hi friends, this is Dr. Kamalarajan, Assistant Professor, Department of Chemistry, RMD Engineering College. Last video, we studied the EMF series, that is electrochemical series, the definition and what are the applications of EMF series. In this video, we are going to study the EMF series application with example. The first application, we know that by finding the EMF of the cell. The EMF of the cell can be easily found by using the electrochemical series. The standard EMF of the cell can be calculated if the standard electropotential values are known, and it can be easily calculated by this following equation, that is E naught cell is equal to E right minus E left. What do you mean by ER? ER stands for E right, L stands for left. And this basic fundamental of electrochemistry can be remembered by remembering these two words. What is these two words? Ox-Lowell and also Regard. What do you mean by Ox-Lowell and Regard? It can be as a remembering word for fundamental of electrochemistry. The first two letter OX stands for oxidation. Then LO stands for loss of electron, and A stands for anode. Then L stands for, you have to write in the left hand side, right? So OX stands for oxidation, means loss of electron, that is undergo anode, and it can be right in the left hand side. What do you mean by Regard? Regard means RE stands for reduction. What do you mean by reduction? Is a gain of electron. So G stands for gain of electron. If it is metal is gain electron, that it's called cathode. Ca stands for cathode. Cathode you have to write in this right hand side. So that I am using this R. So Ox-Lowell and Regard, this is nothing but is a fundamental word to remember the electrochemistry. This is for your understanding purpose. I am giving this example. The second application is relative ease of the oxidation or reduction. A system with high reduction potential has great tendency to undergo reduction. So we can easily interpret the behavior of different elements. For example, the standard reduction potential value of fluorine, you can able to see that the highest value plus 2.87, the higher positive value standard reduction potential value, is shows that higher tendency towards reduction. Whereas metal at the top, you can able to see this metal at the top, lithium, the reduction potential value is minus 3.01 higher volt. So this higher tendency towards oxidation. So metal at the top in the series are always undergo oxidation, whereas metal at the bottom of the series always undergo reduction. The third one, the anodic cathodic behavior of metal. The anodic cathodic behavior of the metal also can be easily identified by using the EMF series. That means metal lying in the higher in the EMF series are anode, and metal in the lying in this bottom in the series are called as cathode. The fourth application is hydrogen displacement behavior. Metal with negative reduction potential will displace the hydrogen from an acid solution. For example, you can take it, the zinc metal. When you put the zinc rod in a sulfuric acid, what happened? The zinc is displace the hydrogen. Look at that. Here the zinc is there. When you are put into the H2SO4 solution, the zinc displays the hydrogen, and you can able to see this, the hydrogen is evolved. This is the behavior of this metal. Metal with a positive reduction potential will not displace the hydrogen from an acid solution. We will see one more example. Metal with positive reduction potential. For example, shall we take this silver? Silver electropotential is plus 0.80. So metal with a positive reduction potential will not displace the hydrogen from an acid solution. Let us take the example of silver, which are having plus 0.80 volt, and you can able to see this equation: silver plus H2SO4, no reaction. The fifth one, a replacement tendency of one element by another. Higher value of the reduction potential shows great tendency to assume the reduced form. So a knowledge of electropotential gives an indication of relative replacement tendency. The metal that have higher position in the EMF series can displace the metal which have lower position in the EMF series. For example, we know that copper will displace the zinc from a solution. We know that the standard electropotential of copper and as well as zinc. You can able to see that the zinc is reacted to the copper sulfate. The zinc is replaced the copper, and you are going to get zinc sulfate plus copper. Zinc is placed above copper in the EMF series, and zinc can replace the copper from copper solution. Then, the predicting the spontaneity or feasibility of redox reaction. The spontaneity of redox reaction can be predicted from the EMF value of complete cell reaction. Positive value of E of a cell reaction indicate that the reaction is spontaneous. If value of E is negative, then the reaction is not feasible. In general, an element having lower reduction potential can displace the another metal having higher reduction potential have from its salt solution spontaneously. If the net of the EMF of the cell is positive, then the reaction is spontaneous. If the net of the EMF of the cell is negative, then the reaction is non-spontaneous. For example, Daniell cell, E cell is equal to ER minus E left. 0.34 minus 0.076, we can able to get plus 1.1 volt. So it indicates that it form a cell. The last application is determination of standard free energy del G naught and also equilibrium constant for the reaction. We know that EMF series are used to determine the free energy and also equilibrium constant by knowing this equation. Minus del G is equal to N of E is equal to 2.303 RT log K. So if you want to calculate the log K is equal to minus del G naught divided by 2.303 RT is equal to N of E 2.303 RT. In this equation we can able to find the equilibrium constant as well as we can able to find this free energy change, and if you want to calculate the equilibrium constant also. So thank you very much.